Okay, so this is a tutorial on some of the homework problems for the review that you can watch and obviously are. So you're asking for the weight of the bottle for the first one. So we have a bottle here. Gravity is pulling down on it. And we know that you can always find the force of gravity by taking m times g. And the thing to remember here is that the mass is given in grams. You have to convert it to kilograms in order to find the weight. That's problem number one. Problem number two, we have a crate and it's stationary. And so we are asking what force is required to get it moving. So if we apply a force to the right, friction will act to the left. There is, of course, gravity, F sub g, and there is a normal force, F sub n. And although these two are the same size, we still need to know that because we're going to try to find the friction force. So remember that the friction force, if something is stationary, the friction force will always equal mu times s times the normal force, which in this case is mu sub s, the coefficient of static friction, times the normal force in this case is the same as the weight, which is mg. And remember, it is equal to, this is the maximum. So this is the force required to get it moving. Once it starts moving, of course, we would use mu sub k instead of mu sub s. And if I push with a force that is less than this maximum force, friction will always equal whatever force I apply. So that's how you're going to figure out the maximum force that's required to get the cart moving. Now, if this force continues to act, so once you find F sub a, that is going to be the applied force. Okay, so in 2a, you found the applied force was equal to this maximum friction force. Once it starts moving, however, you still have the same applied force, but now because it's moving, the friction force is less. This is F of F. And so, to find the acceleration, you now have to say that the sum of the forces equal the mass times the acceleration, and the sum of the forces will be the applied force, which you applied from 2a to get it moving, minus the friction force, equals ma, but now the friction force is going to equal mu sub k times the normal force, which is mg, which is not quite as big as the friction force was up here. So first you're going to find this force, and then you can put it in Newton's law and solve for the acceleration. Okay, on number 3, you've got a beam. It's being lowered by a crane. It's accelerating downwards. So gravity, F sub g, is bigger than the tension force, which is being applied to the beam. You can find F sub g, of course, by taking m times g, and then you'll apply Newton's law. The net force equals m times a. In this case, the net force will be F sub t minus F sub g. That's the difference. And that's going to equal m times a, and then you will be solving this for F sub t. Okay? And remember, the acceleration here is negative. It's moving downwards, so the acceleration has to be negative. Okay, on question number 4, we have a blocking sled. It's pushed by a linebacker. So there's some forward force and applied force. There's a friction force. There is a normal force because the ground pushes up on the blocking sled. And there is, of course, the gravity force, which goes down. So the first thing you want to do is find the gravity force, which equals mg, and realize that's the exact same as the normal force. So we know the normal force. The second thing we want to do is find the friction force, that since it's moving is mu sub k times the normal force, which we found up here. And then once we find the friction force, now we can apply Newton's laws. The sum of the forces will equal m times a, and the sum of the forces will be the applied force, the linebacker, his applied force, minus the friction force, which you found here. And now you can solve this equation for a. Okay, question number 5. We have a truck and it's moving along the highway, and it has a velocity of 11.9 meters per second. And the truck hits the brakes, and so it skids to a stop. And so while it is skidding, there's a normal force on it. The ground is pushing up, and gravity is pushing down. And since it's not accelerating up or down, those are equal. And of course, there's friction on it. Your first job is going to be find F sub g, which equals mg, and realize that that is the normal force. The second job is to find the friction force, which equals mu sub k times the normal force, which equals mu sub k. And since the normal force is mg, there we go, that's the friction force. Your third job is to apply Newton's laws. The sum of the force equals the mass times the acceleration, which means the only force on it is negative the friction force. That's the only horizontal force, so that's the unbalanced force. That equals m times a. And so you can solve for a. And then lastly, once you have a, you know the initial velocity, you know the final velocity because it comes to a stop. So if you know the initial velocity and the final velocity, and you know the acceleration, you can find the distance it goes. The acceleration you get from here, of course, using the equation v final squared equals v0 squared plus 2a delta x. You can solve for delta x, the distance the truck slides. Number 6. Gravity in this case has a smaller value. It's 3.71 on the surface of Mars. Mars is not as big as Earth. And so we have a force pulling down, which is F sub g. And of course, F sub g still equals m times g, but we're going to use this new value of g to find the force on the probe pulling down. Okay? Now, it's got some rocket thrusters, which also exert an upwards force. And let's call that F of t for the thrust. And we know what that is. So we know what the upwards force is. So we want to know what the acceleration is. So we're going to apply Newton's laws. We're going to say the sum of the forces equals m times a. The forces will be F of t minus F of g, and that will equal ma. And then, of course, you can solve for the acceleration of the probe as it's descending towards the surface of Mars. Okay, number 7, I'm just going to do A and B. Part C is a little more challenging problem you can try to work on. For 7, we have an airplane. It has 4 turboprop engines. I tell you the mass, and I tell you the forward force of each of the engines. So basically, you're going to have an airplane. Gravity pulls down on it. We're not so worried about that. And the ground pushes up with a normal force. But there are 4 forward forces, 1, 2, 3, 4, and each of those is the force of the engine. And then there are 2 backwards forces. There's a friction, and I tell you the total friction force. So that's this friction force here. And air resistance pushes back. We'll call that F sub A, let's say. And so what you have to do here is apply Newton's laws to find the acceleration of the airplane. The sum of the forces will be 4 times the force of the engine forward minus the force of friction minus the force of air resistance. That's the net force. That's going to equal the mass of the airplane times the acceleration. You can solve for the acceleration. And then down here in part B, once you know the acceleration, you can figure out the length of the runway that's needed, delta x, because you know the initial velocity is 0. You know the final velocity is whatever I tell you, 65 meters per second for my problem. You know the acceleration from the problem above, and you can figure out how long the runway is. Just please make sure you convert your answer to miles, because it's in meters when you solve the problem using the acceleration in meters per second squared. Okay, and then lastly, 7C asks you to modify this problem a little bit, and so that's a bit of a challenge problem, and 8's a bit of a challenge problem, so I don't want to just give you too many hints there. But in this case here, we're going to add an additional thruster. So we're going to add an additional force to this diagram up here, and that's the force of the rocket engine. So maybe you could say there are now 3 jet engines, because one of them got taken out, and there's a rocket engine. So this is the force of the engine. There's a force of the rocket. You still have the air resistance, and you still have the friction force. And in this case, you know the length of the runway, and so you can find from the length of the runway, you can find the acceleration. When you have the acceleration, you can apply Newton's laws to figure out what the net force was going to be. And then, since you know these 3 and you know those 2 forces, you can find the missing force in order to find the net force.